which will be given by Jonathan Boutro from BureauVeritas. Jonathan is graduated with a master's degree in mechanical modeling of materials and structures from École Centrale Marseille. He joined BureauVeritas as a structural engineer for different types of offshore oil and gas floating assets. Jonathan is now market leader for offshore wind and marine renewable energies, which main objectives are to support the business development network for market intelligence, prospection, and offers, but also to advise on R&D needs and to ensure a transverse view of all BV activities on these markets. So please, Jonathan, go ahead.
Thank you. So good morning, good afternoon, everyone. I hope that you can hear me well and that you can see my screen.
Perfectly.
Thank you. So I'll talk about the different certification schemes that exist for marine renewable energies, but as you will see, I will mainly focus on one technology, which is the floating offshore wind. Just a slide on BureauVeritas. So we have been working on the more than 90 different offshore wind projects, so both fixed and floating, that represent globally an installed capacity of 25 gigawatts. And we have a network of 340 professionals. So it's mainly surveyors and engineers working on this domain. Just to understand the certification context, I think it's interesting to have a look at the key trends of the floating wind industry. So first of all, this is an industry which is transforming. As Flavia and others explained, we're transitioning from prototyping to commercial projects, also including newcomers like the international oil companies, Total, BP, and Shell, for instance. This industry is also very quickly expanding. So we are talking about a two-digit growth of this market in new regions like Brazil. And it's still innovating a lot. As you may know, there are roughly 40 to 50 different floaters concepts on the market, of course, at different TRL levels. And also new materials, or at least new usage of existing components or materials. I can mention, for instance, the synthetic fiber ropes made of polyester or nylon, and also the high voltage dynamic cables. So analyzing these key trends, there are three main challenges, which are how to mitigate the risks of such projects. Second will be to know if the supply chain will be ready to deliver on time and at the quality level expected. And also how to select the most suitable technology for a given project. So considering all these challenges, certification is a way to address them. So in this section, I will give you more details about the certification of marine renewable energies. First of all, you have to know that in most of the cases, the certification is not mandatory. It means that it's not imposed by the local authority. On the other hand, it will be usually strongly recommended or even imposed by different stakeholders, typically the insurance companies. There are several types of certification. The first one I will describe is the approval in principle and also the prototype certification. So that's typically addressed to technology developers and designers in aiming at enabling the go-to-market of new technologies. After that, we can also provide project certification. So here it's mainly addressed to project developers or operators with the objective to de-risk the projects and improve its safety and its quality. If we are performing certification of floating wind projects, because the certification body is in a unique position to de-risk the project. Let me explain on that. The typical setup of floating wind projects involves many different actors. You have the project developer, then you have the turbine OEM, you have also the floater designer, and even the dynamic cable designer. So you have a lot of interfaces between all these different actors, and obviously they have to exchange some information for designing their components. But it's limited due to IP or confidentiality. On the other hand, the certification body is in a unique position to gather all the different information coming coming from different designers, for instance, the turbine controller, because we'll have to build our own independent model, complete model of the wind turbine, so including the turbine, the floater, the mooring system, everything, such as to verify the wind turbine, the loads in the wind turbine. So it's very important to have a certification body on board as a third party, having a look on the entire project. So talking about certification, indeed, this is an exercise of conformity assessment to technical standards. So indeed, the certification schemes or procedures are explained in some guidelines. For instance, the IEC RE for renewable energy OD 502, or equivalently in the BV guidelines NY 631. So here you will find the different certification schemes, the input, the output, and also the process will be described. And as I say, then it will refer to technical standards. So coming back to this example of floating wind applications, technical standards applicable most of the time to the turbine and the tower will be the one published by the IEC TC88 working groups. And so that's the 61400 series. And for what concerns the floater and the mooring system, usually here we'll refer to the classification society's rules. So for instance, the BVNY 572, what concerns the floating wind projects. So just a few words on these technical standards. So the NY 572 will give you technical requirements to be addressed by the designers all along the project lifecycle. So if we focus on the design phase, you will find requirements on the materials, the design conditions, the load cases to be considered, but also requirements in terms of stability, structure design, so strength and fatigue, and also marine, that also covers marine systems. We've also published equivalent guidelines for current and tidal turbines. So that's the BVNY 603. So coming back to the different certification schemes, there are several depending on the type of project, the maturity of the projects. So I've mentioned the approval in principle, which is a concept pre-certification. After that, we can also perform the prototype certification, which is very close to the full project certification. But as the operations of the prototype will be limited in time, so typically during a period of 3 to 5 years, the design requirements will be a bit less stringent as compared to full project certification. And the other difference between prototype and project certification is that a prototype usually will be instrumented. So it means that in terms of certification, we will review the instrument and test plan, which will be provided by the designer. So the next schemes are the component and type certification. So typically for offshore wind projects, the blades are component certified, and then the full RNA, rotor nacelle assembly, the wind turbine, will be covered by a type certificate. So the type certification is not specific to one project. It's covering different types of project, many applications. So it means that in the context of the full certification, or real project certification, we will not evaluate again all the internal components of the turbine, but we will just evaluate the validity of the type certificates. I will come back to that point. Let me give you a bit more details on the approval in principle. So as I said, it's kind of concept certification, so addressed to designers. And the main objectives here will be to establish the design codes to comply with. So for offshore wind, it's obvious because technical standards are already available. But if I consider emerging technologies like floating solar, for instance, it's not an easy task to find appropriate technical standards. So here we have to benchmark the existing design codes and sometimes adjust some requirements to address one specific technology. The next objective of the AIP will be to verify that the design is feasible, achievable, and contains no technological showstoppers that may prevent the design from being mature. So here it's important as kind of de-risking of the technology. And at the end, the certification body will issue comments and recommendations to be addressed during the later the further steps of development. It's because at AIP level, usually the designer cannot consider all the different comments, but let's say the concept will at the end be a prototype, then some additional comments or recommendations will have to be addressed. For what concerns new technology, sometimes it's not possible to certify it as is, and before certifying this new technology, we have to qualify it. So at BV, we have developed guidelines for the qualification of new technology, which are based on risk considerations. So typically, we will perform HAZID, HAZOP, and FMECA, failure mode effects on criticality analysis, such as to be able to qualify the new product, new technology. After what, we'll be able to certify it. So now let me give you a bit more details on the project certification. So as I said, when we'll have to perform the project certification, we will consider the type and component certification which have been performed. So it means that we will evaluate on the validity of the type certificates. So this project certification scheme that you can see on the right-hand side of the slide is made of independent modules that are evaluated by the certification body one by one. And for each module of the certification, we will issue 2 deliverables, a conformity statement for this module and an evaluation report. And if we have to just explain the different phases, you have a first step, which is the certification of the design phase, covering the site condition assessment, the design basis, the loads, and the detailed design. After which we will certify the manufacturing phase, the transportation installation, and the commissioning. So once we have evaluated properly the different mandatory modules, we'll be able to issue the final project certificate. As options, you may include different modules. So there is one named other installations. So typically this module will cover the inter-array cables of the offshore substation, if any. The project characteristic measurements also can be evaluated by the certification body. So that's typically the certification of the power curve. And the operations also can be included in the certification. So traditionally, in most of the cases, the certification will not be maintained during the operations, but it's possible. So very quickly, I will go through all these modules. So the first one is site condition assessment. So here, the key question is to know if the assessment is adequately undertaken by the designer and well documented. So here I refer to the meteocean condition, the wind characteristics, regular wind and turbulence, and also the geosciences aspect. Next is the design basis evaluation. So here it's not only one document, but it's several design bases. So the part A, which is produced by the project developer and mainly addressing the site environmental conditions. Design basis part B covers the wind turbine and the tower. So that's obviously produced by the turbine OEM. Part C will cover the foundation, fixed or floating, and including the mooring system if it's a floating foundation. And part D is for the other items like the inter-array cables. So here, as a certification body, we'll just make sure that the different technical standards and norms used by the designers are coherent at the interfaces, so between the turbine OEM and the floater designers, for instance, and that there is no gap in terms of technical standards. Another thing that will be carefully checked by the certification body is the design methodologies. So at this stage, we will review the load cases, we'll review the fatigue methodology, the load analysis as well. So all the different project methodologies will be evaluated. Third important point is the integrated load analysis. So here it's very important because, as you may know, for floating wind projects, there are a lot of different couplings, notably this coupling between the wind loads and the hydrodynamic loads. So the certification body will have to build its own independent model. So this is, as I explained before, gathering all the information coming from the turbine OEM, the floater designer. such as to evaluate the loads in any point of the structure. So once we have computed and verified the site-specific loads, we'll be able to compare these maximum loads that you will find on the site with the allowable range of loads as specified on the type certificate, such as to validate or not the type certificate of the wind turbine. So let's say that you have validated the type certificate. It means that in terms of detailed design evaluation of the wind turbine, you don't have to do much because it's already covered by the type certificates. On the other hand, you'll have to analyze carefully all the site-specific components. So that's the tower, which is designed for, let's say, optimized for each site, the foundation, floating foundation and the mooring system, and the inter-array cables, if covered by the certification. So during this design evaluation module, we will make sure that the methodologies that were described in the different design bases are properly applied by the designers. And in parallel, we'll also perform independent analysis to validate the results of the analysis performed by the designers. So the next steps are about manufacturing, transportation, installation, and commissioning. So here there are two main activities. The first one is the documentation review. So we will review the quality system of the different sites, just to make sure that the manufacturing site is certified according to ISO 9001. We'll also make sure that the different welders and NDT operators are qualified to perform their jobs. After that, we will also perform regular inspections, such as to evaluate the base materials. So we'll review the steel or different materials certificates, and we'll also witness the different assemblies that are produced by the manufacturing places. So we'll carefully review the different welds, the tolerances in terms of misalignments, etc. During the T&I phases, we'll act in parallel to the marine warranty surveyor, which is another third party acting during the same phase, but looking at different things. So here, we'll just make sure that the transportation and installation procedures are in conformity with the methodologies that are described in the different design bases. So that's the primary objective. So once we have validated all these different modules that I've explained, we'll be able to issue the final project certificate. After that, we could also certify the OEM, so the in-service phase, performing regular inspections, periodic inspections that are based or not on RBI, risk-based inspection regime, and agreed with all the parties involved. So that's it for me for this overview of the project certification. Don't hesitate if you have any question. I can take a couple of them, I think.
Thank you very much, Jonathan, for the nice and instructive presentation. Certification is surely one very important topic in our discussion today. We have one question. I think we have time for one question. I have one from the audience, from Ingrid Silveira. I don't know if you can answer on that, because it's related to wind measurements. She says, what is usually the certification procedure for offshore wind resource measurements? Is there a common understanding about the best practice for this procedure? For example, LiDAR measurements or onshore met masts?
Yeah, so usually a floating LiDAR will be deployed on site. So I think that's maybe the best option and most accurate option. If you want also to optimize the design, I mean, the first step will be to evaluate properly the environmental conditions, because we know from experience that it has a very strong impact indeed on the design. Just maybe the wind turbulences, for instance, may have an impact on the fatigue performance of the mooring system in some cases. So I think it's very important to evaluate properly the site conditions.
Okay, thank you very much. We have to move to our next presentation. Thank you again, Jonathan.
Welcome.